Greetings, math fans. All right, this is the last day of Chapter 3A. Okay, and then we're going to start with Chapter 3B, but this is day 13. And what we're going to do is we're going to do the derivative of more trig functions. Sweet. All right, and the more trig functions are just going to be basically tangent, cotangent, secant, and cosecant. Okay, this is what we did two trig functions the previous day, which is sine and cosine. Actually, we're going to use that knowledge to come up with our other four derivatives. So let's start out here, d by dx of tangent of x. Okay, well I can rewrite that as d by dx of sine of x over cosine of x. And then what are you going to use? We're going to use the quotient rule. Okay, so we're going to say the bottom. So d by dx equals bottom times derivative of the top. Derivative of the top is cosine of x minus the top. So remember, you do the bottom first because you start at the bottom of the corporate ladder. Okay, minus the top times derivative of the bottom. Derivative of cosine is negative sine of x all over the bottom squared. Okay, so let's simplify that. We get cosine squared of x. That's plus sine squared of x over cosine squared of x. Very interesting. Okay, I recognize that identity. Cosine squared of x plus sine squared of x. That's 1 over cosine squared of x. So please don't leave it like that. That's going to be equal to secant squared of x. So d by dx of tangent of x equals secant squared of x. Very important. Put a big old box around that and put a couple stars around it. Okay, very important. Okay, that's our first derivative. Okay, let's do the next one. D by dx of cotangent of x. Okay, well again I can rewrite that one as d by dx of cosine of x over sine of x. So we're going to do the same thing. We're going to do the quotient rule. So that's equal to the bottom times derivative of the top. Derivative of cosine is negative sine of x minus the top times derivative of the bottom, which is cosine of x, all over the bottom squared. Okay, so that we get negative sine squared of x minus cosine squared of x over sine squared of x. And then, of course, I can factor out a negative out of that top there. So I get sine squared of x plus cosine squared of x over sine squared of x. All right, and so the top gives you 1, but it's, of course, negative then. So it's negative 1 over sine squared of x. And then I can rewrite that as negative cosecant squared of x. So d by dx of cotangent of x equals negative cosecant squared of x. Okay, another important one, math fans. Put your stars around that. Okay, that's pretty easy. All right, let's move on to secant. So d by dx of secant of x. Well, let's use our knowledge of what we have here. So it's d by dx really of 1 over cosine of x. Okay, so we're going to use the quotient rule. So it's bottom times derivative of the top, which is 0, minus the top times derivative of the bottom. So minus the derivative of the bottom is sine of x, or negative sine of x, so negative sine of x all over the bottom squared. That gives you positive sine of x over cosine squared of x. And we've done this before. Okay, let's just rewrite that. Sine over cosine is tangent of x, and 1 over cosine is secant of x. So there we go. That was actually pretty easy. So d by dx of secant of x equals tangent of x secant of x. Okay, what are we going to do? Put a couple of stars around it. All right, sweet. So let's keep going here. One more. D by dx of cosecant of x. The same thing as d by dx of 1 over sine of x. And then we're going to use the quotient rule. Bottom times root of the top, which is 0, minus the top times root of the bottom, so minus cosine of x all over sine squared of x. So that gives me negative cosine of x over sine squared of x. Then, of course, I can rewrite that as negative cosine over sine, of course, is negative cotangent of x. And then I have 1 over sine of x, which is going to give me cosecant of x. There it is. So d by dx of cosecant of x equals negative cotangent x cosecant of x. Okay? So we're going to put a couple stars around here. And that's it. Okay? So those are our additional 4 trig functions. So I'm going to write them out here just to kind of give you guys an idea how to keep that in memory. I mean, you can easily drive them. You got to admit, driving it was like 2 seconds if you're not sure what the derivative is. As long as you know the derivative of sine and cosine, because that takes a little bit of time doing limits. But as long as you know derivative of those two, it's easy to come up with the other ones. I mean, you can come up with them like literally in just seconds, okay, if you're not sure. But you really need to commit those to memory. So let's just put those out here. D by dx of tangent of x is equal to secant squared of x. D by dx of cotangent of x equals negative cosecant squared of x. D by dx of secant of x is equal to tangent of x secant of x. And d by dx of cosecant of x equals negative cotangent of x cosecant of x. All right, so let's take a look at this. If you notice, the derivative of the cos, always give you cos, okay? And tangent, which is the non-cos, give you the non-cos. All right. Also, let's just look at this guy here. Of course, secant goes with secant, right? And cosecant goes with cosecant. There. Right? And then just got to remember that these are negative. This guy here is negative, and this guy here is negative too, right? When you have the cos, okay, the cos are negative. The pilot is always the positive person. The co-pilot is always the negative person. Oh, that's kind of random. Okay, but just kind of a way to remember it. All right, so just these have to be committed to memory, though. Memorize. All right, not too bad. Okay, the last thing I want to talk about is something called the third derivative. Well, we know we have s of t, that's a position, and s prime of t is the velocity. Okay, that's the change in position. Then we have s double prime of t, that's our acceleration, which is the change in velocity. And then the next thing is s triple prime. Okay, that is our change in acceleration. Think about when you're in a car and you're accelerating from stop, right? You're accelerating, and you realize you need to get ahead of somebody because the lane's ending. What do? You floor it, and then you're changing your acceleration. What happens to your neck when you floor it? Doesn't it jerk back? Okay, or the same thing, I'm coming to a stop sign and I'm slowing down, I'm hitting my brakes, so I'm decelerating, so I have a negative acceleration, I'm slowing down, and a squirrel jumps in front, which you shouldn't really brake hard because you're going to get rear-ended, but something jumps in front of you, you slam on the brake, so you're changing your acceleration a lot faster. What happens to your neck? It goes forward, right? So it jerks forward, so that's what it is. So the third derivative is called a jerk. Now that's kind of a way that if you want to call somebody a jerk, which is not very nice, but if you call them a third derivative, they'll never know that you're calling them a jerk. You say, third derivative, hold your fist up. They'll think it's something bad, but they won't know. Okay. But I'm just kidding. Don't do that. That's not a good thing to do. But the third derivative is called a jerk because you're actually changing your acceleration, either accelerating really hard or decelerating really hard, and your neck snaps back and it jerks forward or backwards. So that's why they call it a jerk. Okay? Anyway, that's it, math fans. Have an outstanding day. Adios. Goodbye.